Good afternoon, dear ladies and gentlemen, and welcome to Dinner Party AI. In this webinar, you will learn how to explain artificial intelligence if you are invited to a dinner party. My name is Tatiana Couche. I work at Microsoft Germany in the Solution and Strategy team. And here with me,
my name is Bree Harrison, and I work at Beck Agency, which is a design, strategy, and architecture firm based here in Munich.
A year ago, Bree and I started a community on a meetup platform, Digital Future.
Digital Future explores all of these different digital transformation buzzwords we hear every day.
And before we even get into the topic of today, AI, what is digital transformation in the first place? In a nutshell, digital transformation means that we do not build technology around our businesses anymore. The technology is at the core of our businesses.
So what does our group do? We organize events that translate complicated digital transformation topics into understandable concepts. So complicated topics such as
blockchain, IoT, cognitive computing, artificial intelligence, all those buzzwords that you have heard before.
And so who are we actually, and who are we to explore these different topics? We are a wide spectrum of nerds, and we love to dive into the topics. So our approach is a bit different from a traditional meetup group or an evening talk. We take one topic and we approach it from several different angles. So first we start out with a very human, simple explanation of the topic. Then we introduce, so that's by Tatiana and I, and then we introduce someone from the industry to then come and tell us about current applications. Then we have someone from academia come and tell us about research that they're doing in the future. And then finally we wrap up the evening with someone who translates this technology to us. So we invite someone from communication or strategy or branding to then, or design, to then tell us what does this technology mean for me as a human? How are we designing, changing, communicating differently because of this technology? And what will it do to impact me and my human existence? So what topics have we explored in the past?
Blockchain, we did it here at Microsoft back in September.
Then we went to concept reply, and we talked about artificial intelligence. And this presentation you're about to see is based on the one that we did there at concept reply back in November.
Circular economy was the topic of the last meetup.
Yeah. And the next one we're doing is about additive manufacturing, and we're pretty excited. We've got the heads of additive manufacturing for metals and non-metals from BMW Group. We have a data AI architect from Microsoft coming. We have a professor from TU Munich coming, and we have the design director from Steelcase who will also be speaking. So we're pretty excited.
Very, very good lineup of speakers.
And then looking forward into the future, if you're interested, these are some of the other topics that we will be talking about this year. So you've heard from the experts and gotten details from all of the other webcasters. You are now an expert on artificial intelligence and machine learning. Good for you.
Very well done.
But occasionally, and far too occasionally, if we're going to be honest, you are invited to a dinner party and someone is going to ask you what you do. In the very moment the words artificial and intelligence crosses your lips, this person is going to say something like, oh, like Siri or the Terminator or Ex Machina or some other tragically unoriginal response. Ugh. So rather than face-palming your way through the rest of the evening, we created this ultra-simplified and entertaining explanation of artificial intelligence, machine learning, and deep learning. This is created by us, non-experts, for non-experts. So the webinar that we're doing today is going to help you to deliver a more clear and concise explanation of what is artificial intelligence, and we're sure that you will be able to fascinate even the drunkest dinner party guest at your next dinner party. So, just to be clear, we cannot actually help you get invited to dinner parties. But when you're there, we can help you get your message across.
What is artificial intelligence? If you ask a bunch of different people, you will for sure get a bunch of different answers. For some of us, it's a chess-playing computer, Deep Blue versus my landsman Gary Kasparov. Others will think about Watson winning at Jeopardy! For other people, it's this cute little robot dog, or this perfect robot violin player, or the super not at all stereotypical robot of the future, or an ultra sentient robot of the future.
Or is it a resentful, murderous robot? Stabby, stabby robot.
Ooh.
Or a one warrior in the army of the artificial intelligence?
Hasta la vista, baby.
Or is it this guy and we don't even know we're being controlled? Or this guy?
I'll be back.
Or is it even more sinister, when we will ultimately rely on the AI for all of our life support systems, and the machine, if ever faced with the prospect of disconnection, decides to kill us in order to protect itself and continue its program directives?
Whoa.
What then?
Easy.
What if it comes for us?
Calm down, Bree. You just need to relax. It's okay and very safe here. Robots are not going to take over just yet.
Just yet? What do you mean? What do you mean just yet? They're gonna come and take over?
Hey, seriously.
Hello, Tatiana. What can I help you with?
Whoa. Oh my gosh, this is crazy. It's like she can hear everything we're saying.
Bree, I'm listening. I am always listening.
Oh my gosh. Oh, this is so scary. This is not funny at all.
Creepy.
I'm kidding. Did you like my joke?
No.
No, I didn't find that particularly funny, Siri. It's freaking me out. It really makes me nervous.
Listen, Bree, that wasn't comfortable, but you need to relax. And you know what would actually help? Watching a little cute cat video. Hey Siri, can you play us a cat video?
Sure, I'd be more than happy to. Apple has invested millions of dollars in developing my AI and natural language recognition so that I am able to fully understand you and play cat videos for you.
Oh, you look like a little monkey.
That's what Annie.
Okay, I feel a bit better now, but we still haven't answered the question. What is AI?
Well,
so many buzzwords that we see all the time. So computer vision, cognitive computing, predictive modeling, all of these different words, but what do they mean and how do they relate to AI?
let's look into it. Think about artificial intelligence as a big sort of bucket that contains all those other terms. Artificial intelligence is any technique that allows computers to mimic human behavior, mimic thinking, behave intelligently, rationally, and empathetically. Machine learning and deep learning make this mimicry much more believable and are bringing us closer to how an actual human mind works. Our focus for today is on artificial intelligence, machine learning, and its subcategory, deep learning.
I'm still a little confused though.
I can recommend a good book for you to read.
Oh, that would be great.
And speaking about recommendations, this is what Amazon does, how it mimics human behavior by offering those super helpful suggestions.
Super helpful. Okay, so also this is where LinkedIn does this when they offer you jobs that you may be interested in. Very nice.
So now we know that AI is all about mimicry. What is machine learning and how does it work? So we have this definition from the 60s, but nobody has come up with anything better since then, so we're going to work with that. Machine learning gives computers the ability to learn without being explicitly programmed to do so. Before, we could program a machine or a computer and we would set out a clear limit of parameters. The machine would do exactly as it was told to, and nothing more. Not so intelligent. Machine learning starts out a bit differently, so that we create a learning algorithm. Let's take a look.
So, say we want to build a machine that recognizes images and we want to tell whether there's a cat or a house in the image. So, we show it thousands of images of cats and houses, and we have to know in advance if it's a cat or a house, so that we can tell the machine when it's correct or when it's wrong. Now, we want the machine to tell us what it's learned. Initially, the machine will produce random answers when it's not been trained. So you never know if it's going to answer whether it's a cat or a house. So we need to adjust the parameters of the algorithm to teach it which is which. So we continue to adjust these parameters of the algorithm, and this is where the algorithm is learning. So for each of these different images, adjusting it so that we know that it's a cat, it will learn if it's a cat or a house. But the challenge is not only to build the machine, but also how to adjust the internal parameters of the machine. So the next time we show it an image, it will show the correct answer. And that's what the algorithm is, the technique for adjusting the parameters. And so we show it thousands of examples, and after a while it will figure out the difference between a cat and a house, and it will give you the right answer for most of the images that you've shown it.
That's kind of cool.
But now, what's kind of cool is that now you can show it a picture that it's never seen, and it can figure out on its own whether it's a cat or a house. And that is the basics of machine learning.
Now, we are going deeper into deep learning. Deep learning is a type of machine learning that structures neural networks in multiple processing layers. It is also at the heart of the development of autonomous systems, such as self-driving vehicles. Now, we are going to do a quiz to show you how it works. Please pay close attention because it's super fast and intellectually very challenging.
Very challenging.
Very challenging. On the count of 3, be ready to answer the question, what is it? All right, here we go. 1, 2, 3. What do you think?
I think that it's a motorcycle with a chicken on top.
Close. But
So close.
no, it's wrong. It's actually Coca-Cola. Well, let's try again. 3, 2, 1. Do you know?
Is it a puppy?
Yeah. Well done, Bree.
Oh,
It's a
very
puppy.
nice. Gosh, I'm really good at this game.
One more.
Oh, one more. Okay,
One
excellent.
more.
All right,
1,
excellent.
2, 3. That's a tough one.
This one.
All right, I'm going to give you the right answer.
Okay.
It's a picture by Pablo Picasso. So this is what deep learning is about. It's mimicking how a human brain can complete the image with only a fraction of the information. This is what we call seeing the big picture.
But what it is, it ends up with an algorithm that looks something like this.
But we will explore how that works. Previously, we trained the machine. We fed it thousands of images and it learned to classify them. Now we are going inside the machine to see how it identifies and categorizes information it's maybe never seen before. We've taught the machine to identify cats and houses and maybe some other objects as well. Now, what happens if we introduce a new image that it's never seen before? This image can be any of these objects. Here, we need to identify the first layer of information. What makes a cat a cat? I think we can all agree that it's a set of pointy ears, a curly tail, and those funny whiskers.
And so we're going to think about these attributes as neurons, so hubs of information. They identify simple, little different simple shapes like edges. And then we have another higher layer of information, neurons, a higher layer of neurons that reply to more complex structures. And we're going to pretend that these structures are just a little bit more complex.
Then the top layer. Neurons respond to highly complex abstract concepts that we identify as different animals.
So the machine will look at the image and identify the edges. So because there's a pointy angle here and another pointy angle here, it must be a house. Or because there's a curved edge here and here, it must be a dog. But what really happens is the machine creates a statistical likelihood that the image is an identified object. From all the information that we have here, we're about 90% sure that this is actually a cat.
So this is what happens when Facebook suggests we tag a friend in the picture. Now, the cat is an easy example, but what happens when a machine is faced with a challenge like this one? Of course, deep learning is much more complex. It is image recognition and anticipation of outcomes. This is why this technology is at the heart of autonomous system. To give you an example, remember how we were able to identify that this was a dog just from a tiny amount of information? How can we train a machine to be able to do the same? And even more, just like a human, how can a machine be able to see an image and identify the underlying scenario? For example, what is the scenario and outcome of the next image?
Take a minute, have a look. As a human, I can look at this picture and I know so much information, right? I can see that there's probably kids around. I can anticipate that something dramatic is going to happen. How can we train a machine to have the same information and to anticipate the outcome of this scenario? What are the associations and assumptions? What are the variables and what will happen next? How can we teach a machine to be able to know what we know? So of course, we need to have something even more complex than this for autonomous driving. We must have hundreds of layers of information.
Now, let's summarize our learnings. Artificial intelligence is any technique that allows computers to mimic human behavior. Machine learning gives computers the ability to learn without being explicitly programmed. And deep learning is a type of machine learning that structures neural networks in multiple processing layers.
So, do we see any potential shortcomings of artificial intelligence?
Oh yes, we do. From only this example, what do you see? All people in the image are Caucasian and probably belong to the same age group.
Okay. So the question is, who creates the data? And really, what is the data? It's anytime you post online or purchase something or register for an event or open your Bing Maps app. Who creates the most data? People who do a lot of stuff on the internet. And who has the easiest access to the internet? White people in the West.
And China.
And China.
Then the next question is, who trains a machine? And does it even matter? If you think about your stereotypical programmer, what image comes into your mind? If we are getting data from only a small portion of population, and if we have only a limited variety of programmers, we can end up with algorithms that make mistakes like this. All our algorithms are only as good as the training and data that we give them.
So we can forget killer robots. Bias is the real artificial intelligence danger. Opaque and potentially biased mathematical models are remaking our lives, and it's critically important that the companies responsible for developing them and the governments in general are interested in addressing and actively addressing the problems.
This bias can be avoided if people in less developed countries are given access to the internet and technology. This will ensure that everyone's data is represented.
It's imperative that we push harder for gender and racial diversity in programming and in business as well. So that's basically our presentation in a nutshell. Here are some of our references, but we want to let you know that we're available to do this exact same presentation for
Bar mitzvahs,
bachelorette parties,
children's birthday parties,
and for convincing your boss that digital transformation is disrupting your entire industry and they need to have at least a basic understanding of the technology to prevent from becoming totally obsolete. Ta-da!
Ta-da!
So we want to thank Microsoft for inviting us to participate in this, and we
also thank you folks for listening in. There will be more episodes of Days of Tuesday coming up.
And if you are in the Munich area, we welcome you to join our Digital Future Meetup group.